So we're going to be learning about the side splitter theorem. When two or more parallel lines, here we have these two parallel lines, intersect other lines, in this case, these other sides of this triangle, proportional segments are formed. So if a line is parallel to one side of a triangle, this RS is parallel to this side XY, and it intersects the other two sides, then it divides those sides proportionally so that XR over RQ equals YS over SQ. Okay, this is for a parallel line that's kind of embedded within a triangle and parallel to one of its sides. All right, here's a proof of this. Worth looking at. I know that you can get your mind around it. It's pretty straightforward in terms of what's going on, but you know, if you want to see this in action and really make sense of it, take a look and you can ask me questions about it. Anyhow, here we go. We've got these parallel lines, and these are equal lines that are intersecting with them. So if you remember what to do, we can say this is to this as this is to this and set it up as a proportion. Okay, PK over KM equals NL over LM. Substituting in like that, you get that, and when you multiply diagonally, you get this, and can solve for x to find out that x equals 3. And of course, this was not equal to 3. This is 3 plus 1, 4, right? So 3 is to 9 as 4 is to 12. Makes sense. Yep. Check out these got it problems and see how you're doing them. And it's worth noting here that this triangle XYZ, is not in an illustration, and you need to sketch it out, and you need to label everything and make sense of it all. Okay? Yeah. Draw that out, figure out what's going on there. So a corollary to the side splitter theorem, which remember is involving a triangle and then some segment that is parallel to that one of the sides of that triangle, okay? But now we don't necessarily have a triangle. These lines sure will intersect, but we don't need to have that be the case. We just have 3 or more parallel lines, and then we've got 2 transversals. Then the segments intercepted on the transversals are proportional. So AB over BC is equal to WX over XY. Yep, and these lines need to be parallel. Okay, let's check out what that has implications for in a problem. So you might have some real life situation such as this campsite. There are 3 campsites here in the diagram sitting on the edge of the river. What is the length of site A along this river? Well, here we have our parallel lines, and we have these transversal lines being the along the road here and along the edge of the river. Okay, that's what this says. So then we should have proportionality between these segments here. Okay, how do we then set that up? Well, what we can say is if x is the length of the river here, I can just label it x number of yards. So we'll keep those same units. Okay, then what are we dealing with? Well, we've got this length here, x over 8, should equal this length here, 9 over 7.2. And that's how it's set up here. Then we multiply the diagonals, and we divide, and we find that this is 10 yards. This is the length of site A along the river. What about the length of site C along the road? See if you can calculate that using the same idea. All right, now we're going to be talking about bisecting an angle. The bisector of an angle of a triangle, you can see that ray AD bisects this angle CAB on this triangle. Okay, it divides the opposite side into 2 segments with lengths that are proportional to the sides of the triangle that form the angle. So we can say that, for example, CD over DB is proportional to CA over BA. And those are the two sides that form it. And so these are these segments. So this is this over this equals this over this. Yep, let's try it. All right, what are we looking at here? Use the triangle angle bisector theorem. What is the value of x here? And remember, we've got this is to this as this is to this. So you can set that up as a proportion. We know that segment PQ here is bisecting this angle RPS, and so we can use that triangle angle bisector theorem and say that RQ over QS equals PR over PS, like that. And then replacing those numbers in, we can then do cross multiplication and find that we've got a length of 21.6. Pretty straightforward. So what do you think about this one? What is the value of y in this diagram? All right, let's see how you do with these lesson check problems. When I finally show the answers, they're going to be backwards. The last two will be first just for the sake of space, but you'll figure it out. Anyway, good luck.